Good morning, everyone. Welcome to the Google Sensing Python workshops. My name is Qiusheng Wu. I'm an associate professor at the University of Tennessee, and this is my first Geo for Good in person. So I'm very excited here to teach you how to use Google Sensing Python API and also Geemap. So before we get into the details, there's some logistics I want to go through. So make sure you can get all the resources, notebook, and where you can ask questions. And we also have a lot of TA here helping out. So this is on the Geo for Good website. You can see that the description, everything here. So this workshop has two sections in the morning. So starting 10 a.m. to 12:30, we can end early. If you can. I know some time zone difference, people might be hungry. So, and then after they come back, so at 12:30 to 1:30 will be the lunch time, and then we will come back at 1:30, ends at 4 p.m. So in total, it should be around 5 hours, and we have a lot of content to go through. So we might some of the things that if we don't have time to cover, that's fine. But I provide the resources that you can go through by yourself. So I've taught this workshop ranging from 1 hour to a whole week, 24 hours. So we have a lot of things to cover. But for this workshop specifically, we're going to help you get started. Whether you are new user to Google Sensing or you have used JavaScript before and you want to try out some Python and also Geemap, this workshop is going to help you get started. And then think about there's a lot of potentials. This workshop just to help you get started, and then some of the essential things you can do with Google Sensing and also Geemap. Next, you can scan a QR code, or you can type this URL, bit.ly G4G-py, or uppercase. So you get to this document, you just scan the QR code or just type the URL. So this one includes all the links to the notebook and also the exercise. Also, if you want to ask questions after this workshop, or you want to communicate, you can also do it here using Gitter. And we also have how to set it up. So before we get into the workshop, I want to get an idea, a rough idea. How many of you are new to Google Sensing? Like you have never used it before? Okay, maybe around 10. How many of you have used Google Sensing API, JavaScript API, but have not used Python? Okay, maybe 15, 20. So how many have already used the Python API? Okay, yeah, there's a lot. How many of you have used Geemap? Okay, maybe 20. Great, so we have a mix. And don't worry, even the beginners, you will be able to get started. So there's no really technical requirement. As long as you know how to click the buttons, open the browser, you get through this. And we have a lot of TA here to help you out. And so I'm going to scroll down to the end here. There's some of the TA. So Bitlop over there. So anytime you have any questions, just raise your hands. We can help you out. We can slow down a little bit. And then Luis. Okay. Nathaniel over there. Nate. So Nate is a Googler. So he knows a lot more about Geemap. So he helped actually reorganize Geemap. And this is where, actually Geemap is already on the Google Sensing documentation. I will show you later. And Kyle, last one is me. So we have, how many? 5 TAs in here. So if you have any questions during the workshop, just raise your hand. We can help you out. And so here, let me quickly go through the notebook in here. So if you click the workshop notebook, or you can just directly go to the Geemap website, geemap.org. On the left side here, if it's on the left side, workshops, and if you scroll down, you should find the G4G workshops in here. So I've given a lot of workshops in the past. So this one is the most up-to-date because we just released Geemap, I think 0.29. So we increased to 1.0 sometime in the near future. But right now, everything has been tested. It should work smoothly. I don't expect to have any major problems because we have tested on all the platforms and different Google Colab and also local Jupyter. Like I said, all you need is just click the button, and then, but you certainly need to understand and digest. But we can help you out. So everything should be relatively straightforward and easy to get started. So here, if you at the bottom, there's a link open in Google Colab. So Geemap has been pre-installed in Google Colab, so you don't need to install it anymore. So thanks to the Google Colab team and Josh team and Nate for pushing that. So now, but it's not the latest version probably, but you can always update, install it. So for those of you, if you have never used Python before, this is the recommended way. But for those of you who are more advanced, you already know how to use Conda or how to set up the environment, then there's on the second page shows you how to set it up. Again, if you're new, don't bother, just open the browser, Google Colab, you should be fine. But for those of you who want to try it out locally, you can create an environment, you can try it out. I'm not going to go through that because it's not for everyone. But today, again, you will get something out of this because it's just super easy. Click the buttons, render the map, and then you can see the result, you can interact. And so here, this is where the entire notebook, so you can go through that. It's a pretty long document, but it should be very straightforward. So each section, what we're going to cover here is to teach some of the basic concepts of Google Engine, objects, image collection, feature collection, and how to visualize them, how to do some simple analysis, and eventually how to export the result and how to create maps, right? So there are lots of content in here. And next, I'm going to quickly go through here the Google Engine documentation. So if you go through the documentation here and then go to the user guide, get started. And so Geemap is already, I think, integrated in last Friday sometime. So now if you go to the documentation, I just want to quickly show you here, right? And we see some of the examples. So we have JavaScript, we have Python. And so this one here right now is using Geemap already. But we updated, so Geemap has core functionality that the Google Engine team help maintain and develop. And there will be extra functionality that the community and myself will be continue to develop. But you can see, right now it's pretty simple, but this one is still the older version, so in the future it will be add_layer. So the notebook we are going to go through today, we use the latest version. So, and I'm going to show you how you can go through that step by step. Okay, so there's pretty much about, and then we're going to dive into the code. So this workshop is all about get your hands on. So there's no slides, there's nothing, okay? So you really need to just execute and see what it looks like, interact. If you have any questions, just ask, okay? So I'm sure you're going to learn, unless you are already a Geemap user for many years, but Geemap started in March 2020, so it's right after the pandemic, so it's 3 years and a half. And so originally I spent a lot of time, but now luckily the Google Engine team and some engineers have been contributing to this. So it's under the hood, it has a lot of improvement, but in terms of the usage, it's like the same. So if you already use Geemap, there's not much changes you're going to see. Okay, so this is a notebook, and like I said, for beginners that you have never used Python or you have not familiar with Conda, just right-click here, open in a new tab, and then to open this one in Google Colab. As I mentioned, Geemap already pre-installed, but I just released a new version yesterday, so probably it's not in here yet, but we can update it pretty easily. And so a couple of buttons I want to quickly go through. Here on the left side, if you click this one here, this one shows you the table content. So the upper left corner, the sandwich icon, the 3 layers. So if you want to skip through to any section, this one can quickly navigate because it's a very long document. And this is just like the table content, so you can skip through to any sections. Also, the lower left corner, there's a file icon. So this one you can connect to a Google Drive or if you want to. But for today, everything is just within the temporary directory, so you don't need to connect to your Google Drive. And so first thing I would like to recommend is to switch to the light mode. Although Geemap now supports the dark theme, but not all the widgets. So the core functionality already support the dark theme, and there's something that might not work properly. So if you are really into the dark mode, you don't have to change it. But if you want to switch to the light mode, I'm going to quickly show you here. Click the settings button, upper right corner. And then from here, there should be a button for you to switch to light theme. I would recommend switch to now, although it's cool to use the dark theme, but later on, if you see something abnormal, because this is more like IPy widget issue, so it's not a Geemap. So we need to, IPy widget upstream need to fix the issue, but we already have some hacks actually fix that, but not all the components because there are lots of widgets. Questions? Okay, so I'm going to switch to the light theme and then click save. Switch to this one. So once you are done with this step, then I'm going to go back to this one here. Again, if you are advanced users, you're welcome to install locally. We don't have time to go through that. So what you need to do is to install the package to the latest version. So you can press Control slash, or on your, if the Mac computer is Command slash, or just simply remove the hashtag at the beginning. So just select at the beginning, delete it, then previously it's a command, so right where uncommon list line, and then just click the run button on the left side. So there are a couple keyboard shortcuts. You can either Control Enter, Shift Enter, or Alt Enter. So I will show you the differences, but for now, just simply click the button. So this one run anyway. That's it. So this is basically install the latest Geemap version to the Google Colab environment. And there should not be any error message. So you will see here file 0.28.2. We should install the 0.29. Okay, so some of the latest one that I just fixed yesterday. So you need the 0.29 to do that. But in the future, Google Colab will keep updating. So you might not need to install this all the time. But in the future, you just run. You will just walk out of the box. Are we done with this one? Okay. So the next step is just to authenticate. So here, if you come back to the import libraries, again, I would recommend to use the keyboard shortcuts. Okay, don't click the buttons. Those are for beginners. After today, you will be advanced users, so don't click the button all the time. It's going to take you a whole lot of time. So all you need, I recommend Shift Enter. Shift Enter, you will execute that code block and then move to the next one. Okay. But if you want to run this code block and you want to stay there, you want to make some changes, you'll be Control Enter. So if I run Control Enter again, you will see the cursor will stay in that code block. Okay. So Control Enter, stay there. Shift Enter, move to the next one. And there's also Alt Enter. I think on Mac is like Option Enter. You will see it will execute this code block and then create a new empty block beneath. So those are only 3 keyboard shortcuts you need to remember. Okay. Shift Enter, Control Enter, Alt Enter. But you can just use one and then you can create a new code block manually if you want to. Because most of the time we're just going through the code blocks one by one. So it's good to use the Shift Enter and then go to the next one. Any error message? If yes, let me know. I've tested so many times, so I don't expect any problem. So next one, this is where it's going to be having problems. So if you have never used the Google Extension API, you have not creating a cloud project before, this is where you might need help to create that. So what you need to do is to authenticate. Right now, it's a bit inconvenient, but I've heard that it's going to be so much better in the future. There will be no authentication, so you'll be just, if you log in, it will just work. But for now, we still need to go through this. So authentication means you are connecting your account to the Google Extension server. So you need to make sure that it's coming from you. Okay, that's called authentication. And once you run this one, it's going to generate a file on the temporary directory on your local computer. Initialization is like you're already authenticated and you need to start a new section. Okay, because think about you have like tens of thousands of computers. You don't want to overwhelm the Google Extension server. So you need to make sure that you stay within the limit. Okay, so authenticate and then initialize. Again, what's the shortcut for executing? Move to the next one. Shift Enter. Okay, it's simple. And you should see this popping up, and there's a hyperlink there. So just click the hyperlink, and then you need to log into your Google Extension account. So by now, you should already have an account. If not, you're going to take some time to get you approved. So here, this is where some of you are going to have problem if you never create a cloud project. So if you, here under the select project, Do you see something, a default project or something else? If there's nothing in there, empty, then you need to choose a project. You can create a new cloud project in here, but you will need to enable the Google Engine API, so it might not be that convenient. And I provide the documentation here. If you want to do it, how to do that, you can find. So if you go back to the authentication, click this here. This show you the step. I think not this one. Anyway, this one is fine as well. So this is what basically is talking about how to authenticate. So let me quickly go through this one here. So I'm going to use my default project. So how many of you have no project here listed? Just one, two? Yeah, so probably some of the TA can help you create the project. If you already have one perfect, you just leave it as default. Otherwise, you cannot go forward because the cloud project is required to authenticate. So then, just click Generate Tokens. So this is more like temporary token used to generate a file on this Google Colab environment. And then I'm going to click your account, log into your Google Engine account, then click Allow. Okay. Then there should be authorization token here. Click this button on the right. Okay. And then come back to the notebook environment. And there should be an input box down here. Then Control V. Hit Enter. Okay. And you just say fully save authorization token. That means you're good to go. So this one basically is saving a file on your local computer. On Google Colab. If you do that on your local computer, I can quickly show you where the file is located. So if you go to, right now I'm on Mac computer. I'm just showing you, you don't have to follow. I'm just showing you what this step is doing. Is authenticating and then creating a file on the computer or Google Colab. So next time you don't need to authenticate again. So this is one time only. And so the file is actually under your user directory. And so Shift Command period. Again, don't worry if you cannot find it, no worry. So it's under .config under your user directory. If you're on Windows, you need to unhide the directory, okay? And then there should be Earth Engine directory, and there should be a file called credentials, okay? So this file you don't want to share with anyone. I don't want to open it because you are going to see my token. So it's not my password, but it's a token that's equal to the username and the password. So this one, if you want to later on, if you have time for developing interactive web app, at the end of this workshop, we're going to have a section about that. This is where you find your token, and then so you can authenticate, okay? Otherwise, you will need to do that every time. Yes? Oh, okay. So anyway, we'll get back to this one later in this workshop. For now, assume that you already authenticate, and then run the EE initialize, okay? If you run that successfully, it should be no error message. If you have any error message, that means you are either your Google Cloud project is not authorized, or your API is not enabled, or something goes wrong, and then you have to fix that. Otherwise, you cannot go through. Of course, you can just watch, but it's much more fun if you can just play with the code. So how many of you run this line, doesn't work? Any errors? One. Yes? Uh-huh. Oh, there's not rendering. So here, ee.authenticate rather than Geemap.e. There's no input box, you mean?
Yeah, like that. So it renders everything except for the box you're supposed to paste the token back in.
There's no box. Oh, okay. So rerun it again. Some people say that rerun it again. So if there's no input box, run it again and see if it shows up. Oh, restart. So if something goes wrong, go to runtime, and then there's a button here, restart runtime. If you restart the runtime, then you have to import EE and Geemap. You need to rerun the import libraries, okay? So I'm going to pause here for a couple minutes. Make sure everyone passes this step. Otherwise, you cannot do anything with Google Engine. So raise your hand if you are running into issues. Don't be shy, otherwise you cannot follow. So make sure that we have asked the TA to help you with the authentication. And for those of you who already passed this step, then I will suggest you just run these 2 lines of code. Gmap.map is to create a map, and then the next one is to display the map. Okay? So what you want is, if you see the map, you're good to go. If you don't see the map, something's wrong. We need to fix it. Okay? So run these 2 lines. Make sure you see something here, and this is the most basic one is to create a map. We go through more later, but for now, just to show you. Okay? Yes? So if you want to check the current version, so here, if you go, just create any new code block somewhere, and then you can just type exclamation, and then pip list. This one should list all the packages version. But I usually recommend that you install the latest one because some optional dependencies. So this notebook use more than just Gmap, the dependency. There are some optional dependency. So you have to install. So if you scroll down here, scroll up all the way to find Gmap, you should find here, where is it? Geemap here, point 2019.0. If you did not install anything, it will be point 28.2. So that's the, I think Google Colab just updated maybe a couple of days ago. Okay, are we good? So, and from now on, you can just run through that, click the button, shift enter, you can just go through that, and we are done with the workshop now. Just kidding. So from here, I'm going to switch to my local Jupyter lab. I'm not going to use Colab anymore because like I said, if you're really into Python, it's better to use your local environment because you have access to all the files and it's much easier. And there are a couple features that is not supported on Google Colab. It's stated in the notebook, but we let you know if something doesn't work. So don't panic. I know the issue, so if you want, you can try that on local Jupyter. So for now, so here, I'm going to open my notebook on my computer. And so I'm going to do the same thing here. All right, so for me, what I need is to import the library. Okay. If you're using Colab, just wait, okay? I'm going to go to the same code block. So in here, for example, right now, I don't need to e.authenticate again. I'm on my local computer. I've done it before. So what authentication is doing is basically, it's going to go to your computer to look for this file under this directory. If it exists, then you will automatically authenticate, okay? Otherwise, you have to redo it again. So if you're running on a new computer, you need to authenticate again. So basically, so I can show you here again. So it's under your user directory. Someone on Mac computer is under your user and then .config. This is a hidden directory. So if you're on Windows, you have to show the hidden directory under .config and then Earth Engine and then credentials, okay? So most of the time, you don't have to touch it, except if you're trying to develop interactive web app, you need to have the token, and then you can paste it into the web applications. We will come back to this later. And so now I can just run e.initialize. When you run this one, it's going to find the file, the credentials file on computer. If it exists, then you initialize. So you see, there's no error message, so it just works just fine. And then just do the same thing here, gmap.map. And you should see the map, okay? So if you are on your Jupyter lab, if I hover my mouse, it should show up the toolbar, so on the upper left and upper right. If you're on Google Colab, it doesn't work. You have to click it, okay? That's fine. So I'm going to close all my other tabs. Does the font size need to be larger or is it fine? Can you see the code block just fine? Okay. Yeah, so this is as simple as it is. Geemap, okay, create a map that you can deal with Google Engine data. So anyone still having trouble displaying the map? Okay, perfect. So then we solved the big problem. Now let's move to the next step. So when you create a map, you can customize, right? So by default, is using display a global map, and the Basemap is using OpenStreetMap, okay? And unfortunately, we had to remove all the Google Basemap. Just so you know, if you're already existing Google Engine Geemap users, you used to use Google Map, and satellite we have removed because we have to follow the Google Maps terms of service. So we're not supposed to do that. But from now on, OpenStreetMap, but we have alternative that we can use. So the first thing you can customize is where you want to center your map. Okay, so you can passing an argument center equal to a list or tuple. So again, this latitude, longitude. So here I'm creating a map centered around latitude north 40 degree, and then negative 100 is west longitude 100 degree. So it's roughly at the center of the US. You can also pass in a zoom level, right? By default, the zoom level is 2. So just run it, you will see it. You can change it, right? So right now, I'm creating a map centered around the US. You're welcome to customize to any country you like. Just figure out the latitude and longitude, and then you can pass in the argument here. And one thing to keep in mind, Geemap built on top of IPy leaflet. So it's using latitude and longitude. Google Engine is different. Google Engine, if you construct a point, it's longitude and latitude. So sometimes you get confused, but you will notice if something goes wrong. So you just need to make sure the correct order. Okay? So this is create a map centered around the US. And by default, you're going to see this icon on the upper left corner here. Right now, this is not perfectly aligned. That's kind of weird issue. IPy, Jupyter Lab and Jupyter Notebook. So you align well on the Jupyter Notebook, it doesn't align on the Jupyter Lab. If on Jupyter Lab align well, it doesn't. Yeah, it's a weird issue I've raised to the Jupyter team, but it's not fixed yet. But by default, you're going to have this data icon on the upper left, and also there's another one upper right. So those are all the toolbars that you can use. We'll try some of those later. And also the zoom in and zoom out. Also, you're going to have the full screen. You can, if the map is too small, you can full screen. But for Google Colab, you cannot full screen. Okay, so don't try. There's no response. So if I go to my quickly down here, right? If you try to click, it doesn't work. Okay, but you can on the left side here, if you really want, you can right click, and then there's a view output full screen. If you really want, you can do it this way. It will be like this. So the map is pretty small, but you can change the height. So you can make the map height much larger. Then you can do it this way. So, so I can do it. For example, let me go back to here. I can say height equal to maybe 900. Okay, and create a default map and run it again. So this is going to get much larger, and then right click full screen. Now it's a little bit better, right? I'm just saying you don't have to do that, but this is the workaround because it doesn't allow you to do full screen on Google Colab. Yeah, so I think I'm pretty done with Google Colab. You can continue to use it, but I'm going to start from now on. I'm going to use my local Jupyter. Okay, so by default, you have this widget. You can hide it if you want to. So before I get into that, I want to show you what the Google Engine team, especially Nate Smith, that he contributed. So now we have the so-called Geemap core functionality. In the future, in the Google Engine documentation, you'll be import geemap.core as Geemap, and then you can do some of the very similar stuff. So I can quickly show you here. In this step, we import Geemap, but just to show you, you don't have to follow me, but I'm just showing you. If you see that from the documentation, you'll be like this. Geemap.core is Geemap, and then run it. And then I can do the same thing. Lowercase m equal to geemap.map, and then run it. You will see the interface looks pretty much the same under the hood. So for most of the users, you can just import Geemap. But I'm just saying, the core functionality will be co-maintained by the Google Sensing team and Google engineer. So this is a lot more stable, but you don't have so many buttons. For example, upper right, there's only the Basemap, the inspector, and the question mark, and also the layer manager. We improve, add more stuff in the future. But compared to the one I showed you here earlier, there has a lot more. That's because they have a lot of extra. And right now, there's upper left, there's no button in there. But this gives you the core functionality. You can add data layer, you can inspector, you can do some base map, change the visualization. We cover that later, but just so you know, this is going to be more stable. Extra feature will be maintained by the community. So we're gonna add a lot more stuff in the future. So for now, I'm gonna switch back to import Geemap, okay? So that we can use all the full functionality of Geemap. So if you import Geemap core, run this one again, and then it works. So I'm gonna go back to here quickly. Let me turn on this one and create interactive map and scroll down. So by default, this is what you're gonna see. Sometimes if you feel it's too crowded, you don't need this button, you don't need the other button, you don't need the drawing tool, you can hide it, okay? So it will be something like this. Data control equal to false. So the data control is the one upper left where you can source data. We will go through that later. And on the right here, this one is the toolbar control, and also the draw control, full screen control, something like that. So usually you can just use the default unless you really want like a specific button to show up, then you can hide it. So right now you can see it's pretty clean. Right now, except the zoom control and also the full screen is there. Everything is gone. Okay, so it's up to you. If you want to do that, this is how you're going to hide it. And next, let's add some Basemap. Okay, so by default, it's using the OpenStreetMap, but there are hundreds of Basemap available. And this is not something you can do using the JavaScript. Okay, so JavaScript, you are limited to just the Google Basemaps. And I would encourage you, if you're already a JavaScript user, throughout this workshop, try to think about, this functionality, how do I do that in JavaScript? And is it easier to do it in JavaScript or in Python? Okay, they will have their pros and cons. But the nice thing about JavaScript, we can already have those being functionality. It's so much simpler. 1 to 2 lines of code, you can get the work done. JavaScript, you might sometimes need to write hundreds of lines of code. So there are like tens of thousands of code already in Geemap that simplify the stuff and makes it so much easier. So for this one, for example, we're gonna when you create a map, you can pass in a base map parameter, and then you can specify the name of the base map. Okay, you don't need to remember that. I'm just showing you if you really want to, like you can do it. Later, I can show you how you can change it interactively. So for now, we are loading the Esri base map again, so you cannot use Google setup base map in here. And this is one way. So basically, when you create a map, you specify all the base map you want. Or alternatively, you can create a map first, just create an empty map, and then use the map.basemap. So it'll be something like this. So when if you want to do something with Geemap, it will always be m.geemap.map. Okay. So you create an empty map, and then you can display it. So the nice thing about IPy leaflet and IPy widget is like bi-directional. So we can display the map first, and then I can add some data layer. It will be reflected on the map. If you're using Folium, so for those Python users, if you're using Folium, you need to pay attention. Once you display the map, it's a done deal. You cannot go back. So it's a one-way street. Geemap built on top of IPy leaflet is bi-directional. So you can display multiple times. You can, after display, you can change things. You will go back to change the previous one. Folium doesn't have that functionality. Again, it's a one-way street. Once the map is displayed, you cannot modify any data layers. So usually you want to use IPy leaflet, okay? So I'm going to display the map, right? Simple as this. Then this is usually what I do. I want to add, for example, whatever base map you like. You just m.add base map. Then you should be able to, for example, add the topo map. And one thing I want to quickly point out is here. So if you're new to Jupyter Lab or Python, you can type m dot, because there's no way I can remember all the functionalities, all the functions. Use a dot and then hit tab on your keyboard. So this is in Jupyter Lab. I think if you're using Google Colab, it should be automatic. So if you type m dot, usually it should be automatically pop up at least. Yes? I'm not quite sure because I don't use collab all the time. But if you in here, you'll be dot and then hit tab, it will show up the list, right? So I can just select, or you can use the arrow key up and down to select which one, and then hit enter. Okay. So these are all the keyboard shortcuts, and then just passing the parentheses. So most of those are functions or classes. And then move your cursor back within the parentheses, and then press Shift Tab on your keyboard. Shift Tab on your keyboard. Then this is where, if you want to see the function help documentation, this is how you see that. I forgot how you do that in Google Colab. If you hover your cursor, it should pop out automatically. If not, there will be some shortcut. Okay, so you can always ask ChatGPT if you forget something. So here, Shift Tab, okay, or Tab, dot, and then Tab, or Shift Tab. So those are only a couple shortcuts you can remember. So in here, you can see, right, you can pass in a base name, and then whether you want to show the base map by default, and there are some other parameters. So this is how you add a base map, right? And okay, so this is the Esri word topo map. I can also add the open topo map. So I can show you in here. Earlier I mentioned there are two parameters. So you can press comma, comma, and then space. Okay, so if you forget what is, Shift Tab again, right? So right now, for example, I want to add a base map, but by default, I want to hide it. I don't want to show it by default because sometimes if you develop something, you have many data layers. You don't want to show them all at once. When you add the data layer or the base map, you want to hide it by default. I can type show equal to false. Okay. So in this way, it adds the base map, but it's not showing up. So Shift Enter. Okay. And I can come back to the data layer here. Upper right corner, there should be a layer manager. And then if you click the layers button, you see this one. So again, come here, click this 3 icon, and you can turn it on, right? So this is how you add a base map by default. It's hidden, but if you want to show it, you just add base map and then the name of the base map. Okay. And so next, how do you figure out which base map? I don't remember the name. Simple. So Geemap actually has the functionality. So upper right corner here, and then the second row, first icon, kind of the main icon, and we click it. These are all the base map available. So you can just select any one you like. You don't have to remember. So for example, I want maybe Staleman toner. You see, it changed automatically. And you can try anything like, so for example, there are also some Esri base map, for example, Esri, NGO. So basically, Geemap has a lot of interactive functionality, but everything that you interact with the map, under the hood, there's some code executing it. So add the base map, right? If you want something else, just remember the name and then just type that one when you aim to add base map. So I can add, for example, CartoDB dark matter, right? So there are tons of base map available. And this is usually will be useful. You just create a map, add a base map, and then add a bunch of Earth Engine data layers. We're going to do a lot of those later, but for now, just showing you. This right now has nothing to do with Google Engine yet. It's just a simple base map. Create a map, and then change some base map. Questions? So easy, right? It's not that difficult. So if you want to see the entire list, I think that one is based on the XYZ services. So it has 150 or something. But if you want to see all the base map, you can run this line. Right now it's 155. And I can show you the first 10, for example, right? So all we need, for example, okay, I want the NLCD 2021. You just select that. Control C. And then I can come back to here. Just add a base map again. You can write a new line, or I can just Control V, paste, Command V. Oh, no, this one. I need to Command C, and then run this one, Command V, run it. So come back to here, right? You see the NLCD lane cover. This one is not Google Engine, it's just a base map. Yes?
So just with iPad, is it only possible to visualize the map within Jupyter Notebook, or like with Folium or something like that, you can export it?
You can do the same thing. So you can export it as a HTML. So it's similar to Folium, but the downside is that once the map is created, it's exported to HTML, it's a done deal. They cannot interact. You cannot use those widgets. So there's not really whole point. So at the end of this workshop, we have a section how you develop app. There you can actually interact And so that's so much better. Hope we have time to cover that, but for now, I recommend just use IPy leaflet. Okay. Questions? Okay, so then we're done with the first section. We take a little bit longer, but at least right now everyone can get started, can see the map, and then we go much quicker. Okay. So the next section is about Earth Engine data. So Earth Engine, basically, all the objects are server-side objects. It's different from traditional Python programming, the object in a local computer. So think about it's doing the data streaming. So just like you're watching a movie from Netflix, you don't have a movie actually on a computer. It's from their server and you're streaming. So it's the same thing for Google Engine. And Google Engine has these fundamental types: image collection, geometry, feature, and feature collection. So you definitely need to master this. It's pretty simple and straightforward. So image, think about you have a GeoTIFF on your computer. Okay, image collection is a bunch of images. It can be under the same directory, but usually it can be coming from the same sensor. For example, Landsat 8, Landsat 9 is one huge image collection. So there's no limit. It can be an image collection can contain just one image, or image collection can contain 10 million images. So it varies. And then geometry is just the shape. So think about if you have already used some GS, you have a shape file. Okay, a shape file can be considered as a feature collection. It's a bunch of, if you open the attribute table, you see line by line, like row by row. So each row is one feature. Each feature is contained of the geometry and also the attribute. Okay, so the geometry is basically just the shape without the attribute, without the attribute table. And then if you have a geometry, you have some attribute attached to it, it becomes a feature. And if you have a bunch of features, it becomes a feature collection. That's it. So that's more like a high level. And so next, let's talk about how do you actually visualize that. Many of you already JavaScript users, like it's simple. The API between JavaScript and Python pretty much are identical, except there are some minor differences. So everything will be e.doc something because it's from the server. So all the objects will be read by e.doc something, and it's a server-side object. So what we're doing here, e.doc blah blah. Again, this one right now, just like the Basemap, there's no way you can remember everything. So later I'm going to show you how to do that. For now, there's just like assume you already know the name. So every asset in the Google Engine data catalog has a unique ID. So think about that ID just like a social security number. So you have access to right now probably over 90 petabyte of like data catalog. So it's huge. And you don't need to download anything. All you need to okay, I know the name. Then you just grab the name and then figure out whether it's image collection, feature collection, and you just load it. So for now, just run this code block. Let's see what it is. So Geemap, so this one has the rich representation. So kind of similar to the JavaScript. When you see the object, you can see, for example, this image. This is the ID, how many bands, right? And also the property. So you can click it to hide it. And if you are Python user before, you probably used to use .getInfo. You don't need to use it here, okay? So Geemap support, you don't need to use that. So .getInfo actually is not recommended because if I type this one, you will see it's a huge, like non-collapsible. It's very long. So if you like have a lot of attributes, it can be overwhelming. So just type the name of the attribute. You don't need to use the .getInfo. Similar to the JavaScript, you don't need to do it. So unless you need to get some of the value programmatically, then you want to use the .getInfo to pass it to the variable. If you just want to display it, don't use the .getInfo, okay? So just type the name like this, and then you can inspect, okay? So this is how you access to the attribute. And this is kind of like you go to Netflix, you search the movie, and then you see the movie metadata, the cast, the characters, something like that. So just the metadata. And with that, now we can visualize, like, so this is the global DM. I pointed to the data, and then I can visualize. So just run this one. Let's see what happens. Okay. And so what we're doing here, we create a map, and we center the map around somewhere. We set the zoom level, just like what we talked about earlier. And this is where you're pointing to the Earth Engine object. And so for Earth Engine visualization, for raster data, you need to figure out how you want to visualize that. Similar to the desktop GS, ArcGIS, QGIS, you add the image, and then right-click property, and then you change the symbology, the same thing. But Google Engine, doesn't have the interface, or Geemap has. I'll show you later. But for now, everything we're going to do is programmatically. So you need to specify the minimum, the maximum, and because this is a one band, so you can specify a palette, so basically a color map. For multispectral bands, you need to specify the bands. If you really want to see all the documentation, I would recommend you go to here. I can quickly show you. Just for new users. For advanced users, this is probably you already know before. So I'm going to go to image, and then image visualization. And here you can see the table of all the parameters you can customize. I will show you more examples later, but the most basic one is the minimum value, the maximum value. Basically, you want to stretch, visualize based on the range you specify. And then for single band, it's going to be a palette. For multispectral band, it's going to be the bands. Okay, that's pretty much what you need to remember. And take a look. So how you want to visualize, and the function you're going to use most frequently in Geemap is probably this one, m.add_layer. In the past, it would be like m_add_layer, camel case, but we have switched to this like Python convention, use a lowercase. So from moving forward, we're going to use add_layer. And so you can press Shift tab on your keyboard to see what you need to provide. So by default, the first one is going to be object, so it can be image collection, feature collection, geometry, something like that. And the second one is a visualization parameters. So it's a dictionary. So in Python, it's called a dictionary. And then the name of the layer. And the last two is the throw and also the opacity. So you can customize it if you want. But this is the most basic one. Okay, create a map, grab some data, specify how you want to visualize that, add the data layer into the map, display it. That's it. So the whole workflow is going to be pretty much similar for all your Python scripts using Geemap. And so for the palette here, you can provide a list. So a list basically is a hex color code. So hex color code basically means this is 6 digits. So the first 2 digits is red, 3 and 4 is red, green, blue. So basically 6 digits. And hex color code kind of similar to the RGB 0 to 255. So you can change it if you want to, but I think usually for me, I was just passing whatever the name. So for those of you who are familiar with matplotlib, there's a color map, the name of the matplotlib. So I can just type, for example, terrain, single quotes. It should just work, okay? So that you can easily customize it, see? So I don't need to remember the list of color maps. And you can change it to any name. So if the name doesn't work, it will tell you. So for example, if you have any typo, it will go to pseudo error. I can do maybe, for example, cool warm, right? I know that one exists, so it's a matplotlib color map, right? So this one is not something you can do with the JavaScript, okay? You need to list out the longer list. This is so convenient, okay? And so this is how you visualize a single band raster. I'm going to switch back to the terrain, and I'm going to quickly show you what you can do interactively. And this is actually where Geemap is about. It's about you allow you to change things interactively, right? So you can do the coding, and once you finish this, I can come here, upper right corner, okay? And then the street layer. So here, there's a settings button, okay? So if you click the settings button, this one allows you to change interactively. So you can change the color map, you can change the minimum, maximum. So I'm gonna click it. Hopefully no error message. Okay, so this one right now doesn't work. It's all 0, but I can scroll down here, for example, select whatever you like from the drop-down list. So these are all the color maps available. Again, all the names you can just add map the visualization. You can just grab the name. So the name, for example, terrain. So here I can scroll down all the way to the end. Like I find the terrain, and then just hit apply. This one is the same thing, okay? But you can switch it, for example, terrain, reverse. You're going to be very different, right? So easy. So this is more like similar to desktop.js. Add the data layer, and then you can change it interactively. You can not only change the color map, you can also change the opacity. For example, I can switch this one here to maybe 40%, okay? Right. So this is where you can use those interactive widgets. If it's taking too much space, you can click the button to hide it. It should collapse and then stay at the low right corner. If you click the button again, it should pop out again. And thanks to Nate for restructuring everything, so now it's so much better. And you can also change different classes, how many color map, but you can play with it. I'm just showing you. If you don't want to do things programmatically, Geemap has those widgets allows you to change interactively. Okay, cool, right? Global DM, many gigabyte. We're just streaming the data. We don't download the data. So we are watching the movie right now. So this whole workshop is about teaching you how to watch movie, but in geospatial, how to stream the data. And if you master those, your life will be so much easier. You won't go back to just download the data from those data portal. So that's for just one single image. So next, let's talk about the image collection. So again, there are tons of image collection on the Google Sensing Data Catalog. You can go there to search. So for this example, we're going to use the Sentinel-2 surface reflectance. Okay. So the entire sensor, all the images you acquire, is an image collection. So in there, I'm not sure how many, but at least it's 10 million images. So you are pointing to that 10 million images, and then you can filter to whatever you like. Okay. So again, I'm passing to available, and then I'm doing the same thing in here. So look at this code block. We are creating a map. We are accessing the entire Sentinel-2 surface reflectance, and this is the power of Google Sensing. I just take the median. So I'm taking the median value of like over 10 million images, generate just one image. So this is also called reduction. We don't have too much time to go into detail, but just saying you can create a cloud-free imagery, like take the median, because optical remote sensing imagery, right? You have cloud, very bright, value, DN value very high. You also have like very low value, very dark. Somewhere in the middle, right? It's going to be pretty good. Unless like if there's cloud 24/7, then it's not going to work. But this is usually pretty good. So we're taking all the entire image collection, and then we just create a median. This is kind of like in Google Earth. You open Google Earth, it's all perfect, like no cloud. They're all fake. Those are not real imaging. It's basically under the hood, something like this is processing using Google Sensing, and then take the median. So basically every pixel come from a different date, and then it's going to present something like this. And after that, everything else pretty much the same. Specify how you're going to visualize that. And like this one, this is a multi-spectral, so you have the bands parameters rather than the palette. And then you can set the center. Set center here is the longitude, the latitude. It's a little bit confusing. So if you create a map, set the center is latitude and longitude. This set center function is Google Sensing, so it's longitude and latitude. Similar to if you use JavaScript, kind of set center, camel case, and then add layer, right? Pretty much the same. So what we are doing here is that we are processing tens of millions of images and then create a cloud-free mosaic. It's not perfect, but you see it's like loading, and you can zoom out. This is at a global scale. So the nice thing about Google Sensing is the power of parallel processing, and it doesn't matter the location. The more important is your scientific questions, your methodology, your algorithm. Once you figure out if the data is global scale, you can do it at a global scale. You can do it as many time series as you want to. It's going to take some time because this is a huge millions of images. Just run it, you will see it. And later on, I will show you how you filter the collection. Yes? Questions?
Yes. You mentioned the median. Do you have any other grouping? Like, could you use max, min, or like a percentile?
Yes. So here it's the same thing. So for example, I can just do, they are like general reducer, but you can do the min and the max. So in here, I can just type max, maximum. All right. What do you expect to see if I run it? It's probably like a lot of white color because you're taking the maximum, you're getting those cloudy images. I'm going to take some time. It's going to show up, you see, it's going to all white because the max basically, you're taking a pixel. So think about it, it's a time series. So every location you have maybe hundreds of images available. And then, so each image is going to have multiple bands. So for each band, it's going to take the maximum of all the bands, all the overall images, and then just take that. So certainly this is expecting. If I like try min, what's going to happen? It's going to be pretty dark. It's might not be pure dark, but it should be very, very dark. because you're taking the lowest value. Yes?
Another question?
Can you input other formulas in there as well?
Yes, then you will need to use the reducer. So if you, that's a little bit more advanced, but if you go to the Earth Engine documentation, and then if you go to here, references, and then on the left side, client libraries, and there's one called ee.reducer. So the median and the mean max is kind of the shortcut that we use, but you can use like image collection to reduce, and then passing the reducer. So in here, you can get the first one, you can get the maximum, you can get the count, you can get the standard deviation. There are a bunch of things you can do. So this is more like, if you want customized operation, you can use the reducer. More questions?
Yeah, I have a question. When you're doing the min-max, setting those values, is there a good way based on like the image collection or image you're using to kind of know what you should set your min and max as?
Oh, so the min and max, that one doesn't have parameters. Min and max is taking the absolute, so it depends on
Oh,
the
I meant for the
location.
visualization.
Oh, the visualization,
Yeah.
yeah, good point. So here I can show you. Let me go back to this example here, right? And if you already know the data, perfect. So for example, let me quickly show you, right? I can just copy this URL. You can find out the help documentation. So Control V, and you're gonna show it up on the Google Search Engine Data Catalog. And then from there, there's a bands. So this one is gonna show you the min and max. So this is absolute min and max. But for elevation, right? You know the maximum elevation on Earth is like 8,000 something meters. Minimum will be like negative or 0, right? So it's pretty safe. But if you're using Landsat, Sentinel, and then whether it's atmospheric correctly or not, that one might be a little bit confusing. But if you're using the original data, always come, for example, to this help documentation, see what's the minimum and max. Your range should be within the here. That's one way. Second way, if you don't do like open the documentation, you just want to like use directly. So this is usually what I do. So I'm gonna quickly show you here. You'll be like this. Oops. And so assume that right now I have no idea about how I'm gonna visualize that. I'm gonna comment out this one. I'm gonna leave this. Okay. So it is just like this. So by default, you can just create a map and then point it to the image and then just add it. Okay. And then you can figure out data. So the visualization, you can pass in an empty bracket and just run it to see like what it looks like. And it's not good, right? There's no visualization because I don't know the minimum, the maximum, right? So what you can do, we actually covered it later, but the inspector, upper right corner here, click the first icon. So this one pretty much allows you to see what the pixel value is. So you get a rough idea about, for example, I know this is high elevation. If you click, okay, it's 5,000. I click somewhere else, right? It's like 400. So you get a rough sense about the range, and then you can do it. Yes?
Just a very quick question on the minimum and the max. So when I do the get info, I'm supposed to get the information about the bands, right? So I would get the minimum and max. Is there any type of kind of like, do I need to be concerned when I'm exporting the asset to make sure that those numbers are there? Or by default, the bands will be described as minimum and max?
So that one, we have in Geemap a couple functions that you can actually get the min and max. I think I have examples later. We cover that. But if I'm exporting the data from Google Search Engine, I think that one, I'm not quite sure. So whatever min and max already exists in there, it might not always be the same that you see on the image because that's the original image. So when you export, sometimes it's resampling. So for example, 30-meter resolution, the min and max is going to be different from the when you export it's like 90 meter or 1 kilometer. So it kind of varies. But if you just for the visualization, just point into the data there, edit, and then just figure out what's the band value. So here is just one band, but we can also do like multi-spectral band. It will be the same thing. So just use the inspector to inspect roughly the value range. If you want to be precise, just go to the documentation. For all the data, you are going to see like, for example, let me quickly go here. Just show you the multi-spectral band data. So for example, Landsat, okay? And then I'll select the first one.
The get info will return to me this information.
No, get info doesn't, except it is already in the metadata, it will be there.
Okay.
But if it's for compute object, there's no min and max. So metadata is, for example here, right? You want to see the min and the max. Compute object doesn't have that, okay? Any other questions? Okay, so once you have this, then you can just construct the visualization parameters and then replace the square brackets with your dictionary. Then it should visualize that. Okay, so min and max, and then the color palette, or if it is multi-spectral band, then you'll be like this. Okay, and so this one is using the minimum. The image is going to be pretty dark, so I usually recommend if you like want to look at a specific area, you know what image collection you're going to use, and the easiest way is just to like figure out and then just use the medium filter. It looks pretty good, but let me return this one back to the median just to show you some differences. So the median is taking all the images. But one thing you can do if you want to make it even better is to filter those cloudy images and then just have a small subset of images. Because this one right now, if you see, like, it's okay, there's no cloud, but it's a little bit haze, right? It's not very clear, a little bit foggy, right? The reason because there's like a lot of cloudy images. So one thing you can do here is to add like basically 2 more lines of code in here. Everything else remain the same. So we are pointing to the Sentinel-2 image, and this one is telling image collection that I only want the data for 2021. So you can use the filter date, and then the start date and the end date. Okay, the end date is not included. So basically, the start date is 2021 January 1st. The end date is 2022 January 1st. But 2022 is not actually included. So it's basically January 1st to December 31st. So basically, I'm asking, give me the image for 2021 for the entire globe. And then you can also filter by cloud cover. So this one is saying, okay, cloud cover less than 5%. So what this one is doing, I'm filtering the entire image collection. Get that for 2021 and all the images with cloud cover is less than 5%. Everything else, all the code block belong pretty much same. And you can see the differences of this one compared to the one above, right? Any differences? It's so much better, right? So much clear because we already remove all the cloudy images. And this is the power of Google Sensing. It's only change a couple lines, everything else remains the same. It run again, seconds, you get the result, right? So for traditional remote sensing, like you have to download all the images, you need to redo all the processing. This one here, this couple lines called this image in here, I can guarantee you, it's going to take you months to download those images, weeks, and then do all the data processing. And then you need to have computing power to be able to do that. But this is like seconds, right? So fast. Okay, so this is all the images. And one thing I would point out here, right? How do I figure out what function to use, right? I don't know what's the name, the property of the image. How do you actually get this one? Cloud pixel percentage, right? I can never remember how to type, like, there's just so many. So one thing you can do here, right? You can either go to the, let me search this one, just to be more precise. So I'm gonna copy this one, and then just paste to Google. It should find you the documentation. So come back to here, and so the description, image properties, right? So all the image properties are actually from here. So if you want to find one, like cloud pixel percentage, this is the name I use. So all the images in Google Sensing has those properties. They can filter, right? Because it's the date when it was acquired and also a bunch of metadata. So you can filter by metadata. Kind of similar if you go to USGS, you're trying to download some data, right? You go to data portal, select the area, and then figure out, okay, what's the cloud cover, and then some other properties. But I can do that programmatically using Google Sensing. So one thing I usually would do is that I don't want to open too many tabs. I want to do everything within here. So what you can do is, let me go back to the previous one here, right? So this is the entire image collection, right? So right now I'm interested in using this image collection, but I want to be more specific. I want some specific area, specific property. So just like collection, and then doc first, parentheses, and then just run it. So just see the first image. So in that way, you know what property are available. So you don't have to go online to search. And then I can click properties. You see the same thing in here. So this will give you all the attribute. And if you figure out which one you want, right, select Control C, and then Control V, go back to filter the data. So it can be percentage, It can be like date. It can be pretty much anything here. You can utilize that. So basically, just get that a subset of images that you want, and then you can do mosaicing. You can do median, whatever you want, right? This is where exactly what it's coming from. And besides that, like filter date, filter bounds, or just general filter, they are all from the documentation. So you do have to be familiar what kind of things you can provide. Think about this is Google Science is just like building blocks, functions, classes, kind of like you are trying to build a house. Google Science have all those things. Okay, I want to build something like this. You just grab that, you build on top of that. And if you have time, I would recommend just go through the client API, see what's there. Something that you want probably is already there. If it doesn't, you just put a bunch of things together, put it together, and then you can do some operation. Any questions? All right, pretty simple. So this for the image and image collection, and how do you do the filtering. So next, I'm going to quickly go through the feature collection. So this is, if you're already familiar with GS, basically it's just like, think about a swap file, right? You're loading the swap file and then open the data there. So here, very much similar. So feature collection is vector data. And then, different from the image, you have to set the visualization and other stuff. For vector data, you can just pass in an empty bracket. And then you can set the center, that's it, right? So this one is the US census rows, right? This one is probably many gigabytes. I don't know how many specifically, but it's all the row network, census row network. It's pretty detailed, right? It's the entire US. So if you zoom to anywhere, you should be able to find it. And if you're trying to download, open this one using ArcGIS, QGIS, good luck. It might crash, but I don't know. It's going to be huge. And not to mention that visualization, computation is another big issue. But in Google Sending, it's like one line of code, load it, and then see what you like. Then you can think about, oh, how do I want to customize that? What kind of color do I want to use that? By default, it's just black color, right? That's it. So this is how you load a feature collection. And then similar to image collection, you can do the filtering. So we can do the same thing here, right? For the entire US, right? You can filter anything. So similar to desktop, right? Open the attribute table, and then you can like select a row, or you can use the, I forgot what ArcGIS or QGIS use, like you can use the selector to select features that meet a specific criteria. So here, what we're doing is basically just, the only thing that we're doing here is adding this line of code. So filter, so like I said, image collection, feature collection, they all have the filter. So the filter means you can pass in a filter. If you want, again, API reference, ee.filter, right? So the filter in here. So imagine, right, you give me a vector data, and let's say population county for the entire US. I want you to select all the counties that has population over 10,000, or all the county has population less than 1,000, or select US states that with an area greater than a million square kilometer, whatever. So those are the criteria. Everything can be doing here. So it's just like a building block, putting things together. So specifically for this example, very simple, right? We're loading the US census state, and then I want to filter the data to Louisiana, and then I add the Louisiana. So right now, right, you see the Louisiana, it's already here. But you might be like wondering, okay, how do you know the name of the column? So e.filter.eq is like, if the column name, the value equal to Louisiana, I select that. But before you do that, you probably have no idea what attribute name, right? So you have to open the attribute table to see. So what I usually do would be like this. Okay, so I'm going to remove this one. So as long as you know the image feature collection ID, you get the name, and then I can just pass in the name to here, right? Add the layer, and then this is state, okay? And then run it. So this one, we're loading the entire image feature collection for the entire US, right? So just like the image collection, I select the first one to see what attribute available. Feature collection, you can do the same thing. But what I usually do is just load the data layer entirely, and then see what state you want. So you can use the inspector, and then just come back to here, right? Click it. It should give you the attribute properties, right? And this is where you grab the name of the column and also the value, right? So if you want Louisiana, somewhere in here, for example, Texas. So the name of the column is called name, all uppercase, right? You can filter by other attribute if you want to. So specifically, for example, here, once you have that, you can just filter the image feature collection. So this is the feature collection, and then just passing here, doc filter, and then inside here you passing a e.filter filter constructor. So e.filter.eq means, okay, if the name is equal to Louisiana, I select that. And then once you have this is subset of the feature collection, and then you just add it, right? That's it. Right? Very simple. So how do we select California? Just change California, right? It's simple as that. So right? If you can change the layer name if you want to, and then just run it. You see? Now California. You can select multiple if you want to. So by default, yes.
Yeah. How would you show the attributes as a table?
Attribute is a table. You can use the inspector. So here, if you really want to, you can certainly. The Geemap has a function called e to df. I don't think I covered this, but I can show you here. Right. So right now, this one, for example, the state, U.S. state, I can do it like this. You'll be Geemap.e to df. Okay. I don't want to show all of them, but I can show you a couple of those. So for example, states.limit 3. So basically, you can convert that feature collection into a table. But this is usually not recommended. If you have a lot of attribute, it's going to be very slow. But you see, right? This is like you open in QGIS, open an attribute table. Same thing. So e underscore to df, and then just passing your feature collection. So now you can see the name of the column and something like that. If you really want to see the attribute table. So the return is a data frame. So pandas data frame if you want to. So this you can see the name of the column and also the value.
Thank you.
Yes?
Is the vector data stored in a distributed fashion, like the raster data under the hood by?
It's stored in the Google Engine server. So Nate probably knows, but that one is more like on the server, but servers are objects. So kind of like, it's certainly not like ShapeFile and other data format, but it's some kind of vector data format optimized for cloud computing. Kind of like you watch a movie on Netflix. It's just a movie. There's no format. You don't know under the hood how they actually store that, but you can actually stream the data. So you think about it in the server, we have no idea what it looks like. It's not GeoTIFF, like Raster data is not GeoTIFF anymore. It's something optimized, but that one is like only the Google engineers know. Okay, so this is how you store the table, but you can, there are a couple more ways. You can just show the first one. So let me show you here. Usually you can just do this, just feature. Like I said, anytime you can just type the name of the variable, it will show you the representation of the object. So you can see all the metadata, attribute, property, something like that. But if you want, you can also use the to dictionary. So to dictionary is convert that one to a Google dictionary, kind of similar like this. But the dictionary, that one is a Google Engine e.dictionary. So sometimes if you want to get information programmatically, then you need to either use the .get_info or you use to dictionary or e to df or something like that. But if you just want to show the attribute, then just type the name of the variable, then you should be able to get it. Okay, so that's how you filter the image collection, feature collection for a single state. But you can do multiple states, right? So for example, if you're doing research for, let's say, the West Coast, you want to select multiple states. This is the only thing that's changed, right? There's a e.filter in list, and then the name of the column, and you can pass in the list, right? So I want the data for California, Oregon, Washington. You can select it, something like this. Again, if you want, just look at this, right? E.filter, and then there's one here called index. And then click, it's going to show you how you, the function documentation. So I don't know how many functions in total, they're probably like thousands, right? It's good to know what's available. You don't need to remember all the names, but you can do a quick search. But it's nice to at least know, like roughly, you can do this and do that. So it can be, for example, GT, like greater than, right? If you have a column with population or area or something, GT dot something, less than something. So just, we don't have time to go through all the details, but just let you know. Think about you have access to the entire Netflix movie database, free. You just need to know what you want. Okay, I want the actions movie, I want a romantic movie, like you filter. I want a movie that was released last year, released last month, okay, filter date. And I want a specific, like I want like a movie by whatever character you like. Just keep filtering, eventually you're gonna get to what you want, and then you can start doing computation, visualization, something like that. So here, let me show you one more object. So I can actually do, let me show you this one for the entire US. Okay, so I'm gonna come back to this one, showing the entire US, and you can do things interactively. So right now we are doing programmatically, but you can certainly say, okay, I want somewhere like southeastern United States. There's just too many. I don't want to use the list. Then you can do it like this way. I can, on the left side, I can click the button, and then you can select whatever you want. Right? And then close it. So you can do the filter. So Google Gmail allows you to, the drawing, the object becomes a Earth Engine object, and then I can use this one to filter. So if I scroll down right now to this code block here, if you don't draw anything, it will also work. I'm actually passing a default one. So if you don't draw anything, I'm going to use this default bounding box. But because I draw something, it's going to return this one as a e.geometry. And then, so the feature collection allows you to filter bounds. So filter by the bounding box. And then you can take a look. You should see the data layer. It doesn't show up here. Let me create a new. You can scroll up to see it, or you can do it like this. See? So now I'm basically selecting those intersecting with the polygon, and I can do it like this. I can turn the US states off, right? Something like that. So you can do things interactively. Whatever you use, draw on the map is going to be, you can access by map.user.ri. It's going to return a geometry, or you can draw multiple objects. You can return a feature collection. So this can be useful if you want to do some quick prototyping, figure out the data for the area. You can do it like this. So I can draw, for example, draw another polygon here. I can draw another one here. Right. So right now I have 3 polygons. So by default, you can just use the map.user.ri. It's going to get the last one. So it's a geometry. So if it's this one, the last one I draw. But if it RI is, it's going to return a feature collection. You see here? So Earth Engine object. So kind of similar to the JavaScript code editor that you can create object interactively. But this is on the server side. So it's already Google Engine converted to Google Engine object. Yes?
The filter bounds, does it use intersection by default?
Yes. So if anything intersect with the feature collection.
Can you change that? Can you like do within, contains?
Likewise, it's a bit more complicated. It's not as convenient. You can just use the filter bounds. You will have to actually do a map function to the geometry. And so if you go to the documentation here, e.geometry, somewhere here, and there's like intersect, contain, or something like that. But it's by object, by geometry. I don't see a function that you can just do like contain and then one collection on the other one. But it's just a map function. We don't have to cover that, but it's feasible. Okay? So that's it. So now you know how to like filter the image collection. So next, let's quickly talk about how you can actually visualize that. So by default, it's just kind of half transparent, black color. And if you want to visualize specifically, you can do it like this. So the function that I would recommend use is called the style function. So style allows you to style the feature collection to whatever way you want. So again, same line of code. The only thing right now we're creating a dictionary. Creating a dictionary. And then, so here we're passing the color. So this is a polygon, right? So the color is like the outline color, and the width is the thickness of the outline, and the line type is like solid, dash, dotted or something, and also the fill color. So the fill color is the internal. Let's just run it and see what it looks like first, okay? And then we can go back to change it. So look at right now, this is how you can customize it. Everything you need to code it. It's not like desktop GIS you can write, Gmap can do that, but I'm just saying you can do that programmatically. So next I'm going to quickly explain here. So different from the image visualization that we did earlier, right? 6 digits hex color code. This one has 8 digits. So 8 digits means you can RGB. The last two are transparency, so the opacity. So if you're here, I do like FF, means it's like fully opaque, it's not transparent. But the last one here, the other one here, the fill color, I means 80 roughly in the middle, 120 something. So if you want to be transparent, you would do something like this. 00 means it's transparent, there's no color. So if you change it to 00, it should be just the outline. Okay, so this is how you can customize what the vector data to be look like. So now I'm gonna give you a test. So RGB, right? Hex color code FF is like red, green, blue, and opacity. So here, right now it's blue color. Okay, how do I display just the outline as red color, no fill color, just red outline? What do you do here? FF00, right? They're simple as that. So FF00, oops, it's all 0, right? So what else? I just need to change this 0. So oops. So it'll be FF means red, no green, no red, fully opaque. So then you'll be just red color. See? So you can customize that. How about I want to fill the polygon with some kind of blue color, half transparent. So what are you doing here? What needs to be changed, right? So FF is red. Basically, if you have the last 2 digits 0, it doesn't matter what you put at the beginning because it's going to be transparent. But in this case, I want some blue, so you'll be maybe 0000, FF, and then maybe some kind of a 80 or whatever. Like the lower the number, the more transparent, like this. See? So it's up to you what you want. Everything can be changed very precisely. So if you really want to see all the parameters, you can go to the, for example, here, go to ee.FeatureCollection, and then there should be a style function here. And here shows you all the things you can customize. For example, the width, the line, right? So I can change it here. I want it to be much thicker. Okay, maybe 10. Don't do that, okay? It's going to look ugly. But I'm just showing you can customize it to whatever way you want, okay? For example, the line like solid, you can change it to, where's the line type here? Like solid, dotted, dash, right? So we're going to Control C, come back to here, run it. See? So Google Sensing basically, if you want to learn it well, it's read the documentation. Everything is there. So all you need to just know to like how to call the function, how to pass in the correct type, that's it, and then you can easily customize it. One thing I want to point out here is that in Python, you need to put 2 stars. So 2 star and then the name of the function. Don't just put like style. You're going to get an error. Okay, so this is for beginners. Usually run into this issue. You construct a dictionary and then just pass in. It will throw an error, right? Because when you pass in a function, you need to provide a parameter, something equal to something, something equal to something. But with the dictionary, you need to unwrap the dictionary and then passing is like keyword argument. So this is where the 2 stars that's going to be used, right? Just remember those 2 stars is to change the dictionary to like keyword arguments, something equal to something, because the dictionary is something colon something key value. Okay, and lastly, let's like do a little bit more complicated one. So this one allows you to like change to customize the data based on the name, based on a column. So here I'm adding the US state, and these are things I want to customize by the color, opacity, whatever. And then you can specify what color do you want, right? What color palette. And so Gmap has a function called add style vector. Just give me a feature collection. Tell me what column you want to do the symbology, right? You can based on population, based on the name, whatever. And then give me what's the color you want to customize, right? So this can help you easily create, for example, a semantic map like showing the population, the color changing from red to green or whatever, right? And then that's it, pretty much. So here you can just easily customize, right? I can change it to whatever color you like. I can add another one at the end, okay? For example, I can do maybe red color. So what's the hex code for red color? FF0000, right? Something like that. So you will be able to actually change you want to see some red color, something like that. So this can help you easily customize. So the column name here, right now I'm using the name, doesn't really have any meaning. It's just rank those alphabetically, okay? So why worst return is red color? Why is it red color? Because when you rank the state name, it's like towards the end. So that's why it's red color, right? If they at the beginning, use like the color on the left. So you can easily customize. So this is mostly just like one line of code allows you to customize vector data based on a column. That column can be string, can be number, can be anything, okay? Again, just adapt the example and just change it to the data you want. You should be able to figure it out. Okay, any other questions? Yeah. Yes?
What about if I want to add my own feature collection?
Good question. If the feature collection is already in your account, then it's the same thing. Just all you need the ID. But if the data is only locally, then you can either upload to Google Sensing or there's a function. But there's a limitation. So if the data is on a local computer, I think like maximum like 32 megabytes something. If larger than that, you have to upload. But if you have a small swap file on your computer, then you want to quickly convert to vector data, you can do that. So Geemap has a function called here. Let me can show you one example. You'll be Geemap. Yeah, you're going to do that with the code editor. Yeah. But in here, you can shift SHP, for example. Oops. SHP to EE. So if you have a small swap file, you have something on a local computer, you want to convert to feature collection very quickly, you can do it this way. So it's certainly possible. It can also be GeoJSON to EE, something GeoJSON to EE. Let me see if I can find you a quick example just to show you what it looks like. Because basically, if you have a small set file on a computer, you don't want to upload it back to your asset. You just want to do some quick prototyping, and you want to use that. So I can, where is it? Let me find a quick dataset just to show you where it is. So here, my GitHub account, and I'm going to go to my, where's the organization? I just want to find some sample data set I can show you. So for example, data, and let's say I have some a GeoJSON of a country, for example, here, right? And this one right now is just a pure GeoJSON. It can be vector, it can be any other data format you want, as long as GeoPanda supported, you can do that. So right now, okay, I download this GeoJSON. It should be under my left side here, right? It's available right now. Is a GeoJSON. So if you want to quickly convert this one to vector data, if you're using a JavaScript code editor, you need to convert to swap file, and then from swap file upload it. But Geemap has like one line of code, so here I can just do fc equal to geomap.geojson to EE, and then just passing the file name, so it'll be country or continents, okay, continents.geojson. That's it. You see, run. Because it's a pretty small file. Now this one is on the Google Sensing. So in here, I can just create a map. So map.gmap.map, and then m.add layer, okay, fc, and then m. It's work. Hopefully it doesn't crash. When I run this line, it's not executed yet until you display it. Until you request the data. It might take some time, so if the file is pretty big, this might be slow. So if you have a file that's, you see, this is what happens, like sometimes you do things on the fly. So there might be some, okay, exceed the payload, right? That's it. So the file is too big, it doesn't work. So,
Sorry, so regarding the file size,
how
do you know upfront what the file is?
yeah, so usually it's like, for vector data, I think if it's over 10 megabytes, don't do it. I think the true limit is 32, but yeah. So here, let me try another one. Like, I want to show you something that actually works rather than It fails. How about this one, countries.geojson? Maybe this one works. So it depends on the complexity of the data. If you like have many vertices, the more vertices you have, the larger the file size, the less likely it's going to work. So this one is countries, and I hope it works. I think I tried it before. Okay, this one is perfect. This one works. So you can convert a small file. Again, look at the file size. A small one, you can do it like on the fly. So here, go to downloads. Right? This one, the content is 8.1 megabyte. It's too big. The other one, the country is only like 240K, so it's small file. So it allows you to convert on the fly. And this is actually the advantage of using Python, is that allows you to communicate with your computer, and then can convert data on the fly to Earth Engine object. JavaScript doesn't allow that. So you always have to upload data to your Google Earth Engine account so they can access the data. Any other questions? So looks like we are 1 hour and 30 minutes. So we still have 1 more hour. Maybe let's give a 5 minutes break, and then we can come back. So get some water, or 5 to 10 minutes. Okay, when everyone is back, we can go through other sections. Any other questions? Yes?
So it sounds like when you load a layer, like it's an Earth Engine object, obviously that's not being loaded into memory, right? So
No.
So how much memory is like an Earth Engine
memory.
object?
You can do
even
that anywhere.
taking? It's
So what this is doing, you can think about, is pulling the data layer, just like you're seeing Google Earth image-based layer. So the data is not on computer. So the data based on your zoom level and also the map view. So I can show you here, like right now, this one, for example, this data layer, maybe I need to run, let me run this one, just to show you what's under the hood, what's actually running. So right now, what is you are seeing here, this data layer, if you see me zooming, right, it's going to pull the data layer. What is actually pulling is actually just a URL. So I can show you, if you go to create a new code block, and then m.e layers. So what we are using actually is this URL. So that data layer is this URL. So when you zoom in, it's going to request the tiles. And you can certainly, if you want, you can upper right corner, and then go to more tools. And then I think it's, what's that, developer tools or something like that. You can see on the fly how it's actually functioning. So when you are pulling the data layer, when you zoom in and zoom out, I think I need to show the network tab in here. So see when I zoom in, you see, it's like scrolling, and if you go up here, these are all the tiles. So think about the data layer in the Google Engine. So when you zoom in and zoom out, it's changing the map view and also zoom level, and it's going to calculate what tile. So it's just like a pyramid. And then when you zoom out, zoom in, zoom out, it's going to request the tile. If it is already requested, you don't need to, but it should change. So if I zoom out a little bit, okay. Oh, if I need to scroll to the end so they can see the changes, right? So anytime it's basically requesting the tile, but it's not requesting the original data. It's just PNG, download the smaller tiles and then put it all together. So this is why sometimes it's a little bit slow when you are requesting, doing a large data processing. It's going to take some time to compute and then pass in the tile layer. But under the hood, everything is just a URL. Yes?
So the question is not totally related to that. It's more curiosity, because I've been reproducing what you're doing in the RGE using the R version of it. And I'm just curious to hear more about the development of both. Are they going together? It's the case that for R is a little bit like behind Python.
Not always the case. So R has a lot of, so R was originally developed by what's the name, Cesar. So has a lot of advanced functionality, but I'm not involved in that. So if you're an R user, I would recommend using it. Under the hood, you're actually converting some of the code to Python, and then or even to REST API. So everything we're doing here, you actually for Google Engine server, it doesn't matter what you use, it's converted to REST API, right? And then eventually it's just running the REST API. So the Python API, the JavaScript API, or even the R is converted to the REST API. So technically, you can just learn the REST API, but it's not as user-friendly as Python. But eventually, it's just like sending the command and then to the Google Engine server, and then to request, and then do the computation. The results are being sent back as a URL. So every Earth Engine object, whether it's image collection, feature collection, eventually what we are visualizing is everything is just like a URL. And then so the URL, you will see here, there's XYZ. The XYZ is when you zoom in and zoom out, your XYZ changes. So it's going to pass in the number to that, and then getting the tile, and then downloading the tile to the computer. Exactly the same, just like you are visualizing Google Earth. If you open Google Earth, Google Map, it's the same thing. So for example here, I can just map.google. Right, so if you open the browser and we see the tab, so right now this is Google Map, but it's under the hood is just PNG. So for your computer, you'll be developing tools, and then the network, right? So pay attention when I zoom in. You see, it's getting all the tiles somewhere, and if you zoom out, if it's already requested, it doesn't do that, but it's a lot of internet network connection. So of course, if you don't have internet, you cannot use Geemap, Google Engine. So it's requesting on the fly. Otherwise, it's impossible. So think about the Sentinel-2 that I showed you earlier, right? Tens of millions of images, hundreds of terabytes. How do you download all the data all at once? No, it's requesting only a small section. So when you are zooming at the global scale, your large area, but the resolution, it doesn't use the native like 10 meter. It's probably using like 100 kilometer. So the file size is pretty small. When you zoom in, the resolution becomes higher, but your extent becomes much smaller. So eventually it's just like doing all the web mapping, requesting the tiles, and then display it. Yeah. Okay, we need to take a break, maybe 5 minutes, and then we can come back to continue. And we move faster. I think we are behind schedule.